Yes, ma'am.
Court, you want to get your mood lighting real quick?
Yes, ma'am.
Marvelous. All right. So this is from the second worksheet, number 9. We're just going to use this as kind of like a warm-up problem. Make sure we remember how to do the stuff we did yesterday. Number 9, second worksheet, solving equations. All right. What is the least common denominator? 5x squared. And what is the excluded value? Excluded value, what can we not have? 0. X cannot equal 0. Okay. So I'm going to take my entire equation, I'm going to multiply it by 5x squared. All right. So what happens with the first term? It cancels except for an x. So the 5's cancel, and then 1x cancels, and it leaves x times 1 behind. What about the second term? Cancels completely, and then the 3 is all that's left. What about the third term? Cancels out completely, leaves the x squared plus 7x plus 6. Okay? And so the equation that we are solving is actually a quadratic. I can tell because it has an x squared and it has an x and it has some numbers. So if I combine like terms, I get x equals x squared plus 7x, and then 6 and 3 makes 9. And to solve the equation, it can't equal x, it's got to equal 0. So I'm just going to subtract this x over to this side. And so when I factor this, I'm looking for two numbers that multiply to 9 that add to 6, and that's going to be 3 and 3. And so my solutions are a little bit redundant. They're the same. And what is my answer? -3. And since -3 is not my excluded value of 0, that means I'm good to go. Alrighty. So there should be 2 contributions in the pile on your tables. One should be your quiz, because I handed the quizzes back, so the quiz should be in the pile on your table. And then the solving equations worksheet, you do not have to rip them apart. You can leave the blank one that you did not do. If you didn't do any extra credit, you can leave the blank one in there, that's fine. So one of the solving equations worksheets still in that packet needs to be in the table, in the middle of the table. All right, so let's go ahead and get our notes out from last night. We're going to finish them. You do need a graphing calculator for today, so if you do not have one of your own to work with, go ahead and please trade me something, one of your 4 ID cards, a student ID card, some car keys. No, but it has your face on it, so I'll be like, hey, this kid owes me $100. Your dead graphing calculator you can trade me. A cell phone can be traded. Not a pencil, no. Credit card's good, I'll take that. Yeah. I will use the credit card to buy another calculator if you do not return one. Huh? What? So we've got the beginning of our notes filled out. If you did not do the video notes, you need to skedaddle into the hallway to take your notes now. It's a little bit of a walk of shame. Oh, skedaddle, skedaddle. Oh, bye, friends. Bye, friends. Yes, we do have to do that little bit of learning ahead of time. Bye-bye. Bye-bye. We'll miss you. We won't. Oh, well, yeah?
No, please, it's actually a glare though on this side.
Oh, there's a glare for her.
I was
So we're gonna.
actually.
Yeah. She usually like leans forward, cranes her neck, and has a squint. She ducks her head under the squint. Okay. So we got the notes. Any questions on the notes that were on the video last night? Is there anything that was weird about it? Anything that was confusing? Yes. Asymptote. So an asymptote is an imaginary line, and what we notice about the curves is just that they get closer to the line. And previous to now, we always thought they could never be crossed, and for this unit, they won't be. They won't get crossed. You'll notice that the curve just gets really, really close to it. When you get into more advanced classes, you will find that they can be crossed. It's not often that they do. So sometimes you'll have, like, let's say this is the asymptote. Sometimes you'll have a curve that will like go up and over the asymptote, and then it will come down and get close to it. So it'll get crossed, but just one time, and then then the curve will approach the asymptote after that. Sometimes we see something really crazy where a graph will be what's called oscillating. Oscillating means the graph goes back and forth. And sometimes you'll have an asymptote and the graph will go up and down and up and down. And as it goes up and down, it will get closer and closer to the asymptote. So it will go up and down, so it's oscillating, but it's oscillating closer and closer to the asymptote as it goes, which is really interesting, but that's a more advanced graph. So that's not something we're really looking at this year, but it is possible. So it will not always be 0 and 0. So we're going to see some examples where it actually, so like this one, it's actually, example 1, you can see that your asymptote is at -1 and +1. And then example 2, the asymptote was at -5 for the vertical asymptote and then -3 for the horizontal asymptote. So the asymptotes actually, they work like the H and K. They work like the vertex almost like we saw before, but instead of it being a single point, it's the intersection of two lines. Yeah. And those lines, they show up, I think, on the color calculators. I think the color calculators might show as a dotted line. Did anyone confirm that when they were watching the video? Did you see that? I don't know if anyone graphed those. I think the color calculators might graph those as dotted lines. I'm not sure. The ones that are not color calculators, I'm pretty sure they don't graph them at all. So they might not show up on calculators at all. I'm not sure. Anyone with color calculators want to graph this real fast and just confirm? Does it show up? Also, just a reminder, it doesn't show up at all. To do the fraction this way, we're going to do alpha y equals, and that's how we get a fraction on our calculator. Like this, 1 over x plus 5. If you try to type this in, oh, well, I guess I should be graphing it like this. If you type this in and you do not do a fraction 1 over and you type x plus 5 like that, you're actually graphing it incorrectly. Your calculator's doing 1 divided by x, and then it's adding 5 to the whole thing, instead of doing 1 divided by x plus 5. So if your calculator is not updated, then you have to do x plus 5 in parentheses like this. Okay? All right. How about increasing and decreasing? Were we okay with that in the video? That made sense? Do I need to zoom in? No? Okay. All right, let's go ahead and do the x and the y intercepts. So we all need to type this in on our calculators. So we're going to do alpha y equals to get that fraction in there. 1 over 3 parentheses x plus 5 squared minus 2. If you have an older calculator, you're going to type 1 divided by, and you're going to have to do a double set of parentheses. Well, kind of. You're going to do one set of parentheses, hit the 3, and then like that. But you're going to have an extra parenthesis in there for people with older calculators. You'll know that you have an older calculator if you hit alpha y equals and it did not let you put the fraction in. So if you were able to put the fraction in, you can kind of ignore me. But people with older calculators, this is how it should look when you type it. You're going to hit the up arrow for people with older calculators, but it's not actually going to bump up there. It's going to have, well, actually, it might actually do the squared. Hi. Yes. Shinko. Yes, thank you. All right. So this older calculator people are this is what it should look like. Okay, we all good? We got it typed? All right. So there, I need to fix my window. Anyone else need to fix their window? Nope. Okay, I was using that in calculus. Huh? Because we had to zoom in. Thank you. All right, so how do we find the x-intercepts? X-intercepts, what do we do? Second trace. Option 2. Second trace, option 2, what do we do? Do you guys want to scroll to find them, or do you want to do the left bound, right bound by plugging our own numbers in? It doesn't matter. You want to scroll? Yeah. So I'm going to scroll to the left, just holding my left arrow down. I got to do my left bound, so I got to get just to the left side of my x-intercept, press enter. And then I got to scroll to the right, get just to the right side of my x-intercept, press enter. Hit guess, ignore the guess because it's dumb, it doesn't give us a right answer ever. Press enter one more time, get 0. So the x-intercept on the right is negative 4.592. Are we getting it? Everybody should be participating in this part, making sure that you can do it on your own calculator, not just watching. We're doing second trace, 0, finding the other one. I can see that the other one is between -6 and -5. So I could type my left bound is -6, my right bound is -5. That's another way of doing it, is typing what numbers the calculator should look between. So second trace number 2. The y-intercept, I always do second trace number 1. James, I remember you did it a different way. Can you tell us again? And if you hit trace, then you can type a number and it works? Okay, so if you just hit the trace button and hit 0. Oh, gosh, that's nice. Hit trace and then hit 0, and then, now if you do not like this, because that is a very not nice fraction, the reason it gave us the answer as a fraction is because when we typed in the function, we typed the function as a fraction. So if you don't like that because it's uncomfortable to you, go back into your y equals, take your equation, go to the very end, hit the math button, right down here, hit the math button. Option number 2 says turn it into a decimal. So if you go to the end of your equation and hit turn into a decimal, Now, when we go back and we look for any y coordinates like that, instead of having those outputs be fractions because we typed it in as a fraction, it will actually allow those outputs to be decimals for us, which is a little bit more comfortable, I think. So let it graph again. And now if we use that method that James figured out, if we hit the trace button, plug in 0, you can see that our output this time is a decimal instead of being a fraction. A little bit nicer, yeah.
Whenever I do that, it just takes me back to the home screen.
It takes you back to just the regular screen. When you press trace, it takes you back to that screen? So press graph, and then press trace. Now it's working. Now press 0. That's very strange. Okay, we'll just do second trace then. Second trace, option number 1, and plug in 0. We'll have to do it the other way. So now we've got that our y-intercept there we go.
Right and left x-intercept, or would you
Nah.
know?
Nah. No, we would just write down what the x-intercepts are. Call it good. All right, next page. Actually, looking at this, let's just do it real quick. Can somebody say what the vertical asymptote is? -5. X equals -5. And you can tell from the equation itself, so it's the opposite of the inside of the parentheses. What's the horizontal asymptote? Y equals -2. So we make sure that when we do the vertical asymptote and the horizontal asymptote, we always say the opposite, or we always write the equation, because it's the equation of a vertical line, it's the equation of a horizontal line. Based off of these answers, can you guys tell me what the domain and the range is for this graph? So these are basically excluded values, excluded for the x, so excluded for the domain, excluded for the range, because it's an excluded way. Very good. Somebody else want to tell me what the range is? Now the range on this one is a little different because this graph only goes up. It does not have both directions. So it doesn't have a bottom half and a top half. It only has a top half. So it'd be what? -2 to infinity. Okay, good. And you don't what? No brackets, because these values are excluded. They are not part of it. If I said, hey, show me where the graph has a y equals -2, where there's a coordinate that has a y value of -2, you wouldn't be able to show them because it's an asymptote. So the curve's getting really close to a y coordinate of -2, but it's not actually happening. Okay, good question. All right, let's do the very last page. So the last page says, look at the left arrow and look at the right arrow, okay? Now, if we look at the left arrow and if we look at the right arrow, what do you guys notice about those left arrows and right arrows? Do they go up or down? Do the left arrows and do the right arrows go up or down? Do they go up? Do they go down? The left arrow and the right arrow? Is that going? Wait. Is it going down, though? It's leveling off. Where is it leveling off at? The asymptote. Which one? The horizontal asymptote. And what value is the horizontal asymptote always? Look back in your notes. Look back in your notes. Well, read the part about the asymptotes. We circled it. I told you to circle it, highlight it. It's not Y. It's K. Horizontal asymptote is always K. The horizontal asymptote is always K. Okay, look at your end behavior again. So for this, our end behavior is always written as, We look at the left arrow, and we used to say, does it go up or down? For these graphs, it never does. It does not go up, it does not go down, it goes to the horizontal asymptote, right? Look at these pictures. I gave you two of them. I gave you one for the 1 over x graph, I gave you one for the 1 over x squared graph. Neither of these pictures has the left arrow or right arrow going up or down. Both of them have the left and the right arrow leveling off. Do you guys see that? Doesn't go up, doesn't go down, it just goes flat. And it goes flat at the horizontal asymptote. So I'm going to write that in my notes. The left and the right arrows always flatten out on the horizontal asymptote. Always. They don't go up or down, they always flatten out. The horizontal asymptote is always y equals k every single time. That's how these graphs work. So when we write the end behavior for these graphs, we're going to say as x goes to the left forever, y goes to what? K. As x goes to the right forever, y goes to k. It's going to work that way for every single graph this entire unit. No question, every single time. When we do the end behavior for this unit, we are never going to get an infinity or negative infinity as an answer for these. Never, ever. Because they always go to a horizontal asymptote. So this unit is kind of unique for end behavior because we're never going to get the answers we're used to getting. But we're always going to get a predictable answer. We're always going to get the horizontal asymptote number. Okay? Does that make sense? Can you see it in the picture why that would be true? Okay. So your notes are completely finished. I'm going to go ahead and hand out the assignment. It's going to feel a little bit like deja vu, like you guys have done these before, because we're going back to those old graphing assignments we used to do all the time. All right. List the transformations. And then I gave you guys a hint. I said write the equation of the asymptote, making sure that we're actually writing those correctly. I want you to label with the asymptotes which one is vertical or horizontal. So I'm saying write the equation of the asymptotes because that's our replacement for write the vertex or write the locator point, because that's what we do for these graphs. So of the following, which one should we do? Should we do, we got 1 through 8. Which one do you guys want to do? 4. Do we want to do 4? 4? 6? 6? Okay. Now, remember in the notes video, I said that we could rewrite this a certain way to make it a little easier on us. How could we rewrite this one? I said we could kind of pull out the a value and make it like a coefficient for the fraction. Remember how I said that? So how could we pull this out and make it a coefficient? How could I pull out a coefficient for that whole fraction? I could pull the 9 out. So I could write this as -1/9 times 1 over x minus 3. Do you guys see how that works? When I pull that out, is that true? That would give me that fraction? Okay? And when I do that, does it make it a little bit more clear what that a value is? Okay, so if I write my transformations, in the front I've got a negative and I've got a 1/9, and that is 2 transformations. What are the 2 transformations? Okay, reflect over x and vertical compression. Okay, what else do we have? Right 3 and up 8. Okay, now we're not finding a vertex, but we are finding a vertical asymptote and a horizontal asymptote. And the vertical asymptote is what? X equals 3. We're not just going to say 3, we're going to say x equals 3. And the horizontal asymptote is y equals 8. Very good. Okay. Okay, we can do number 4. How should we rewrite number 4? You've got the right idea, not quite fully right. Yeah, so take the 3 over, pull it out, and then it'd be 1 over x plus 9 squared, so 3 times, not third squared, 3 times. All right, so what's the 3? Stretch, so we got a vertical stretch. Left 9. Up 2. What's the little exponent? Is that a transformation? No. What is the little 2 telling us? Yeah, it's telling us that the 2 curves are not on opposite quadrants. They're not on opposite corners. They're on the same. They're on the same side. So they're either quadrant 1 and 2, or they're in quadrant 3 and 4. That's what the little square was telling us. They're 1 and 2 since it's positive. It's a positive coefficient, so they're quadrants 1 and 2. Okay, vertical stretch of 3, left 9, up 2. Okay, and then vertical asymptote, horizontal asymptote. All right, what do we have for our vertical asymptote? Yep. And what's our horizontal asymptote? Okay. Yeah. Now on 7, I'm not going to go over it fully. I'm just going to talk about how to rewrite it because I think after I rewrite it, you'll be able to do it. So this one does not have parentheses on the bottom, and that's because the only thing that could have been there where you wouldn't have to write parentheses is if it said x plus 0 squared minus 1. That's what it must have been for them to not need to write parentheses. Is that good? You can do it now? Marvelous. All right, let's go ahead and flip the page. Let's make sure the rest of this makes sense. Okay. No, we were not done. So you guys have your tables of values. I did not do a graphing example of those, but I'm going to be honest with this one. Let's do a couple of these. We're going to do these together. When I graph these, I do not do 5. I do not do all of the points that are on this table. I'm going to be honest because I don't want to. Okay, I'm just going to be real with you guys. I do the vertical asymptote, the horizontal asymptote, and then I do like this point and this point, and that's like all I do because I don't want to do the fractions. So I do like just 2. I do like just 2 points because and the nice thing, I think the reason why I'm okay with it, the reason that it works is because we know that we're going to follow the asymptote, so we kind of know how it should look after that. Does that make sense? We know that you graph like the 2 points and then follow the asymptote and then you're gold. All right, so let's go ahead and start the graph for number 9. So the first thing that we're always going to graph is we're always going to do the vertical asymptote and the horizontal asymptote. And so what is the vertical asymptote? And then what's the horizontal asymptote? Y equals 1. Okay. You don't even really have to do a table for this one, to be honest, if you understand the graphs well enough. So the positive version of the graph would have been in these 2 corners. We are doing the negative version of the graph. So should we be in these 2 corners? No, we should be in these 2 corners. Okay. So the points are they're -1. They're like 1 box away. If you look at it, it was +1, +1, and -1, -1. But we're in opposite corners, so we're just going to go one box away. So instead of being +1, +1, we're down here. Instead of being -1, -1, we're up here. Are we okay with that? Did I mess with anyone's brain too much? So +1, +1, because we're doing the negative version, we just went down here. -1, -1, because we're doing the negative version, we just went up here. Okay, am I good? Are we good? Okay. And then from there, we go, oh, just follow the asymptotes. The P is silent. Asymptote. Nope. Asymptote. There's no P at the end. One of my old coworkers used to say asymptote with a P, and it used to drive me insane because she was a math teacher. And I was like, you as the teacher cannot pronounce that wrong. She'd be like, all right, let's draw our asymptotes. It would be like very pronounced asymptotes. And I'm like, okay, let's look at how to spell that word. You are saying asymptote. You're saying asymptote. It is clearly asymptote. Tote bag. Asymptote. And she said, yeah, asymptote. No. Asymptote. There's a P in the word, but it's silent, and it's in the middle, not the end. And I wanted to make a dead baby animal for the wall every time, and then make her mark it every time she said asymptote.
Are there any animals who can go?
Yeah, puppies.
Oh.
Yeah, the puppies are prevalent. All right. Okay, let's try the next one. Vertical, horizontal. What's our vertical asymptote? Okay, vertical asymptote x equals 4. Horizontal asymptote x equals negative, y equals, y equals -2. Do I need to go find Court? Where is he?
Well, Corey and Court also looked at the same time, and then I kept popping mine to like watch it, and then like keep up, and then Court.
Okay. All right, so this is a little squared. What does that tell us? They're going to be on the same side. It's the High Court. We were just discussing where you were if we needed to send a rescue party out. Or if somebody needed to like throw their long hair out a window so you could climb it. All right, so this is a squared, so they're on the same side. Are they both on the top or both on the bottom? They're both on the top. So we're going to go one box away and draw the points. It's always one box. Always. Well, it's not always one box. Is it always one box? Maybe we should actually do the transformations. Somebody said, no, I don't think we need to. And then we just follow the asymptote. Asymptote. Oh.
It sounds like it should be both.
I think it's one box unless there is a stretch. Asymptote.
That's a completely different subject.
That's triangles.
All right. For these ones, I want you to do these without a calculator because it's a good practice, and the calculator would just make you lazy. So when you do these, I would recommend drawing a little sketch so that you have a sketch of the graph to work from, okay? So domain and range and end behavior, all we need to do this is we need to know what a general sketch of the graph looks like, and then we can do these just fine. So which would you like to do? 13 through 16, which one?
15. 15 divided by 5.
Okay, let's do 13. I heard more people say 13. So for 13, the two things we need for domain and range is we need the vertical asymptote and we need the horizontal asymptote. Those two things are key for finding the domain and range. So what's the vertical asymptote? X equals -1. What's the horizontal asymptote? Okay, so I'm going to draw a little sketch of this because I know that my domain is pretty easy because it always has a left half and a right half, but my range could be a bottom half and a top half, or it could be just a top half, or it could be just a bottom half. So the range is the answer that's going to change up, okay? The domain, that's going to be pretty consistent. The range, that's something I probably need a little sketch for. So I'm just going to draw the asymptotes. There's -1, there's +4, okay? My equation says it's got a squared on it. What does the squared tell me? They're gonna be on the same side, so either both on the top or both on the bottom. I've got a negative in the front, that tells me they're both on the bottom. Yeah, you're fine. So I'll draw them both on the bottom. All right, so the domain is what? Okay. And then when I look at this picture, I can see I don't have a bottom half and a top half. I only have a bottom half. So what does that tell me? -infinity to 4. Okay. Now, I need to write my end behavior, so I'm going to say, as I look at the left arrow, what number is the y value getting close to? 4. That's the horizontal asymptote. As I look at the right arrow, what value is y getting close to? 4, the horizontal asymptote. So that's the expectation for the types of answers that you're going to have for 13 through 16. It's not required to find this information, but that's the information you're going to need to be able to do it without a calculator, and I do not want you to use a calculator on these. Okay? Right. Let's keep looking through the packet, make sure we understand the instructions. Okay. Increasing, decreasing intervals for the following. We are not using a calculator, so what are we going to need to find so that we can do these problems? What are we going to need to do? Vertical and horizontal asymptotes. We're going to need to draw a little sketch. Which problem do you guys want to do, 17 through 20? 18? We're going to do the most complicated looking ones every time. All right, so what's the vertical asymptote? Good correction. And what's the horizontal? Y equals 6. Okay, so I'm going to draw a little sketch. +6, -3. Okay, so we've got the squared. What does the squared tell us? They're on the same side, so they're either both above or both below. We've got a negative in front. They're both below. All right, so I've got my stick figure. Here's my -infinity, because that's a left arrow. Here's my right arrow, that's a +infinity. And then what's the x value right here? Because it's not a left arrow, it's not a right arrow, it's an actual number. So what's my x value right here? -3. Okay, so my stick figure starts walking. He's walking over a hill and he falls down into the abyss, but which way was he walking to do it? Down. Because he's walking down over a hill. Wouldn't you feel like gravity was pulling you down if you walked that way? I mean, you're walking to the right, but you're walking downhill. Yeah. All right, so he falls down into the abyss. He dies. There's a whole bloodbath. There's like gators down there because it's in Florida. I don't know what's happening. And then this is October. It's a little bit spooky, so there's like a satanic ritual down there. And somebody else, like Frankenstein style, comes out of his body and is resurrected. And so here's a new stick figure. So there's a new stick figure starting at -3, coming out of the abyss, and that new stick figure is doing what? Increasing or decreasing? Increasing, coming out of the abyss. No, this new person is a woman because women trample the hearts of men and are resurrected. Right, ladies? I said, right, ladies, and I made eye contact with Keldon. He rose a fist. All right. Decreasing. The interval for decreasing is? What's the word decreasing in between? Negative infinity, -3. Constant. Constant is when it's flat. That only really happens when you have a horizontal line or in piecewise functions, and we saw some of those. Just creasing? No. Just creasing? Just like folding a piece of paper? No. All right, increasing. -3 to infinity. Done. I think at this point we're probably good. The next one is fine. Intercepts, we can do that. That's calculate and behavior. We've already done that today. The last one is just plugging numbers in, which I think we are okay with. So the important thing about the packet is just no calculator. Okay? No calculator. All right, you guys ready? And go. Go, 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 go. Yes, I'll put on some music. You're welcome. Marvelous, marvelous.